Okay, so today we're talking about lesson 8-3, which is called the tangent ratio. The tangent ratio is a ratio that you find in right triangles that has to do with similar right triangles. So let's look at a couple of these. Let's make a small right triangle here. That looks like so. Let's say it's a right triangle and it has one angle as 40 here, which means the other angle must be 50 since the three angles together add up to 180. And let's say I have a bigger triangle here with the same degrees. So we have a right angle, 40, and a 50. Now, as we discussed in chapter 7, these two triangles must be similar, right? The AA similarity postulate, or the angle-angle similarity postulate, says that these two triangles must be similar, which means what? It means that the side lengths, or the corresponding side lengths, must be proportional. So, if I have this side length as x, and this side length as y, and let's say this one is P and this one is Q. The proportion we could set up is as follows. You could say that x over y equals P over Q, because those are the corresponding sides, right? Those are the corresponding sides. Now, what's important to note here is that you can use the properties of proportions to show that it is also true that x over p equals y over q. And I mean, the algebra behind that's not that complicated. You're pretty much just multiplying both sides of the original equation here, of this original equation. If I multiply both sides of that by y, and then divide both sides by p, then they would just switch over. So if you don't believe me, try some numbers. You'll see that it works. So basically, what that says is, I mean, that's not the point of this. The point of this is that the ratio of the legs, right? The ratio of the legs will be constant with all right triangles that have these angle measures. So no matter how big or how small the triangles are, if the angles are 40, 50, 90, they will all have this same ratio, x over y, or p over q. Okay, so the ratio of the legs is constant for similar right triangles. Okay, that ratio is called the tangent ratio. That's what the tangent ratio is. It's the ratio of the legs. And we'll look more at exactly what that means in a second. Okay, so the ratio of the legs is constant for similar right triangles. So, let's look at an example. Let's say we have right triangle ABC. All right, we have right triangle ABC. And what this says, if we want to look at the tangent ratio, let's say we want to look at the tangent of angle A. The tangent of angle A. What that means is you're going to look at the ratio of the side lengths in a specific order as well. So I'm going to write this down in the top corner here. It's a phrase that we'll piece it together with our future lessons as well, but it's a phrase that I want you to remember. It's not even a phrase, it's just a word that's not really a word. It's this, it's TOA. T-O-A. TOA. What that means is that if you have the tangent, it equals the opposite side over the adjacent side. So in this case, again, TOA, so TOA, tangent equals opposite over adjacent, TOA. So tangent equals opposite over adjacent. So the tangent of A is a ratio, it's the opposite side length, right? So the tangent of angle A is the opposite side length to A. So here's A, In the bottom of our screen we have A, and I want to show the opposite side length to A, which is what? BC. The opposite side length to A is side BC. So we're looking at the length of BC. Now the adjacent side length to A just means, again, we're looking at the leg. We're not looking at the hypotenuse. So I'm going to highlight the hypotenuse here. We do not care about that side length. Tangent is just the legs. Okay? It's only the legs. So the opposite leg is BC. The adjacent leg, meaning the leg touching side A, or angle A, the leg touching angle A, is AB. Okay, so the tangent of angle A is the ratio of the leg lengths, the opposite leg over the adjacent leg. And you're going to hear me say this all the time, TOA. Okay, so TOA. So again, just to be clear, this arrow, if you're wondering why it's still there, it's pointing towards the opposite leg. Right? It's pointing towards the opposite leg. The adjacent leg is just the other leg, or in other words, the leg that touches at A. Right? So it's this leg here. It touches at A. So we'll look at an example with actual numbers, so it's not so general. And then I'll show you, we get to use a calculator a lot in this section, so I'll show you how to do that. Okay? So if we have this right triangle, looks similar to the other one, triangle ABC, we know it's a right angle. If it's not a right triangle, it won't work. Okay? If it's not a right triangle, it will not work. So let's say that we know that this side length is 11 and this side length is 13. There's a couple of things we can do. I'm going to show you how to write it in shorthand, because we're not going to have to do this where we have tangent of angle A, right? We don't have to do that. What we want to do is we're going to write it in shorthand. It's much faster. So instead of writing tangent of angle A, you're just going to write tan A. So that's shorthand for tangent of angle A. Okay, so tan A, again, is the opposite, which I'll write as OPP, op over adjacent. Again, TOA, T-O-A, TOA, right? So always remember TOA, T-O-A. Tangent equals opposite over adjacent. So what's the opposite side length to A? Well, here's A, down here at the bottom of our screen, here's A. So the opposite side length of A is 13. So we say that tangent of A equals the opposite side length, which is 13, over the adjacent side length, which is 11. The opposite side length, which is 13, over the adjacent side length, which is 11. Now you don't have to choose A. You could look at angle C. You could look at angle C. So let's say we're looking at angle C. If I wanted to find the tangent of C, right, now we're starting here at this angle. We want to look at the opposite side length of C, which is now not 13, it's what? It's 11. So it's 11. And the adjacent side length to C, or the leg that's touching C, is 13. Again, we do not do anything with my hypotenuse. You do not have to do the Pythagorean theorem to solve for your hypotenuse here, because the tangent ratio only involves the leg lengths. Okay, it only involves the leg lengths. So, what is the purpose? I can sense that you're wondering it already. You're just saying, why are we learning this weird ratio, this TOA nonsense? Let me tell you. Let's say you're in a situation where you are walking down the street and you see a person in a window. That person right there. You see a person in a window, and that person is really high up. It would be very, very difficult to figure out how high up that person is. But if you know the angle that is formed between that person and the ground where you are standing. Right? Let's say that angle, for example, is 32 degrees. If you know that that angle is 32 degrees and the building is straight up, right? Well, we're assuming it's not the Leaning Tower of Pisa, it's straight up, then we have a right triangle. Okay? You can much more easily, at least, measure the length from you to the building. That's not that hard to measure. You can walk it, you can pace it out, you can use one of those wheel measuring things. I forgot what they're called, but we'll see them later when we do an activity. But let's say that you are 125 feet away from the building, and you're solving for how high this person is. Okay, you're solving for how high the person is. To do that, you're going to set up a tangent ratio. So your tangent ratio will say this. You have the tangent of this angle that we care about here, which is this angle down here. The tangent of that angle. What angle is it? The tangent of, it's 32 degrees, right? So tangent of 32 equals, again, the opposite side length. The opposite side length, or leg length, of 32 is h. We don't know what it is, we need to solve for it. Over the adjacent leg length, which is the floor you're standing on, which is 125. So if we're solving for h, all you have to do is multiply both sides by 125, and you get h equals 125 tangent of 32. Now I'm going to stop here for now. If you want to see how to get this in your calculator, to get the actual height, because obviously you don't know what 125 tan 32 is off the top of your head, so you kind of need to plug this into a calculator. I'll go into more calculator problems on there. So watch part 2 of this, and you'll see exactly how to solve this type of a question. Alrighty, see ya.